to introduce the first one, Regina. Regina works at the Instituto de Neuroscienza de Alicante in the lab of Alejandro Gomez Martin, and she'll show us how to play magic tricks to deep neural networks, untangling human deception. Please, Regina, take it away.
Thank you. Can you see my screen? Okay, perfect. So, well, as she said, my name is Regina Zaghi. I'm a first-year PhD student here in Spain. And the goal of my PhD is kind of finding ways to study human cognition outside of the strains of lab and in the real world and in real world scenarios. So I've been working with these wonderful people for some time, and we've been playing magic tricks to deep neural networks to try and untangle human deception. So basically what we're doing is we're using magic as a tool to study human cognition. Magic seems like a great source of information to study cognition because there are a lot of processes and biases in our brain that allows us to get fooled by magicians, but also we are enjoying it while we're getting fooled. So it's kind of like a great experience to have. So I am not doing the magic, right? We're working with a professional magician, Miguel. And we started actually studying the magicians themselves and the tricks that they were doing. And we started using DeepLabCut as a tracking tool to see the fingers, to see the coins. We started seeing the movement, how fast they were, if we compare with other magicians. So there's a lot of things you can study from a magician, and we're already working with that. And then we also focus on the public. What is the public seeing? How is it reacting? The public is really important for our magicians because magicians cannot trick themselves. So they need a public to trick someone else. Now, the public, they're gonna work as groups and they're going to react also as individuals. So there's a lot of things to see here as spectators. The thing is that while we were doing the tracking, we realized that there might be another subject that we can be using to study or to compare cognitive maybe ideas. And that's when we realized that there were maybe 3 subjects that we want to put attention in our research. So we have the magician that I put a yellow color, like the spotlight of the magician, the human spectator that they have gray matter on their brain, so that's where they're green, and the blue cold machines, right? That's the blue ones. So we have these 3, and we were already working with the first 2, but we wanted to focus a little bit in what to do with the machine. So the DeepLabCut, it's a software for tracking with deep neural networks. It also had the convolutional layers that work with score maps that create likelihood of maps to find the location of the labels that you created. And it's also trained with ResNets that have that they come from this bank of images that give a reference to the machine. So knowing this, what we want to do was basically turn this deep neural network tracking system into an artificial spectator. Now, to do that, we have to tone down a little bit of the whole magic experience, right? So we chose some magic tricks that they were only visual and that they have some things that they could be tracked by the machine. So we had 5 magic tricks with coins. So we made a video and we made a lot of repetitions with the magician. We trained the DeepLabCut and then we test with the rest of the repetitions. But the training that we did, we showed the machine that there was a coin. We also showed that when you close the fist or when you're not seeing the coin, you can still see it. I mean, we tried to show some object permanence, something that we learned when we were little. And we were training it as a naive spectator. That means that we were training it as someone that does not know exactly what's going on, that's not the trick, right? Now, with the humans, Miguel Angel has been working for a long time and he knows that these tricks work, right? He knows how to fool us. But we have some weird results with the DeepLabCut because there's sometimes that it's getting full, sometimes that it's not getting full, right? So for us getting full in humans, it means that the trick worked, but for the machine, it means that the prediction that it makes, is showing the reality of what's happening, the thing that the magician knows. So there are some times in which you can see that the machine can do it and sometimes that it cannot. Now, if we go to think about all the cognitive processes that are involved here, there are a lot. And this is a paper that summarizes some of these most important cognitive process involved as a spectator, right? Because the magician is going to play with lots of things. He's going to play with the input of images or to our senses, right? It also knows that we want things to continue the way we already know. And if they don't continue, they're going to create a big contrast. And in those contrasts, it kind of grabs our attention, so it's kind of misdirecting us. It also knows that we have perception, and in that perception, we kind of fill blanks with concepts we already have, and also with the memory of events that we learned in the past or that we learned in that moment. The magician is always creating subliminal messages, and it's kind of forcing us to make decisions so the tricks kind of work. So that's what we know that it's happening to us in our brains, right? So we want to see if we can compare it somehow to the machine. So right now I'm going to show you the tricks, but you're gonna have to try to pay attention. They're gonna be a little bit fast. First you see the trick, then I explain the trick, and then we see what's going on with the magician. Just remember that this is not the same experience that's being in the theater with the magician, so be kind of gentle with that. So let's see the first trick. Okay, so I hope you can see that it's throwing 2 coins and then suddenly the coin is already in the hand, right? So what's happening here is that instead of throwing the 2 coins, it's just throwing one of the coins, and there's another hidden coin that he's launching really fast with a lot of talent, because I've seen it in real life, and you just can't notice this, right? So this is what's happened with the machine. The machine is already tracking that there are 2 coins and both of them are also falling. So it's kind of not knowing what the magician is doing. It's also not seeing the fast coin that's going on over there. So for us, we know that there's some postural inference that the magician is playing with how we think things are going to continue. And maybe it's doing the same to the machine. Let's go to trick number 2. I really hope you don't have that much lag, but if you can try to understand what's going on. So the magician is showing the coin and then it's tossing it to the other hand and then it's magically disappearing. So what he's doing is that he's doing a false deposit. He's actually not throwing the coin, and it's in the same hand, and then it's just putting it back in the pocket, right? So this is what happens with the machine. It sees the coins, it thinks it's going to the other hand, but it's actually not going to the other hand. So it's gonna got tricked a little bit too over there. So yeah, again, the magician is working with occlusion. We assume that the object permanence is still in the hand, but with the speed, he's kind of tricking us and the machine. So let's see trick number 3. So, okay, lots of things are happening here. There's 2 coins in one hand, there's 1 coin in the other hand, and a lot of things are happening really fast. What's actually happened is that there are 4 coins and he's always dragging 1 coin, right? So for us, that's a lot of information happening really fast, but the machine, it's also a tracking software, right? It's not a problem to see which one is dragging and which one is not dragging, and so it's not going to fool the machine because it knows that there's something there. It doesn't feel that information overload that we have, right? Let's see trick number 4. Now this trick, it works better when you're in person, right? Because he's putting the 4 coins, but the 4th coin, you're not supposed to see it in that moment because he's kind of putting number 3 and 4, but when he's doing that, he's showing the other coin in the other hand, and it's also seeing the coin in the other hand. So when you're there with him, you see where he's seeing, right? So there's a misdirection. Now with the machine has no problem. It really doesn't care where the magician is looking at. He's just finding the coins, and that's the task, and he's doing it. So it's not getting pulled by that. No misdirection of attention. For us there is, but not for the machine. And in trick number 5, okay, let's start again. So what's going on here is that we assume that he's grabbing one coin in each hand, but he's actually grabbing no coins in one hand and 2 coins in the other one. So it's a really simple trick to do, just knowing that we are going to assume something really simple. The machine does not have those simple assumptions, right? So it's not going to get full. It's just going to track what it sees, no matter where the magician is putting the hands, right? So it doesn't have that modal perception or that trying to fill the blanks, right? So when we start trying to see actually what's going on, there's a lot of things happening inside of each of these subjects. And there are a lot of things that are different for them. Some they might be comparable, some might not. For example, the human knows that there are some coins. It doesn't know exactly the number, but the magician and the machine both know exactly the number of coins. Nevertheless, sometimes the DeepLabCut gets tricked and even knowing the number of coins. Now, there are other things that humans know, like what's a coin, what's the concept, how does it work with other things, how does it weight, it's not going to simply disappear. The machine does not have this information. It has the reference from ImageNet, right? As humans, we have object recognition. We know it's a coin, but DeepLabCut, maybe it's recognizing features we not really know, right? Also, DeepLabCut works with frames independently. So you can put the video on reverse and it will still find the coins. And for us, that wouldn't work, right? So there are a lot of things happening inside of each of them that are constrained sometimes, and sometimes they're just opportunity for you to compare and think what makes the human experience as a cognitive being experience a magic trick, what makes a machine, what is the machine actually trying to do, right? We cannot say it's thinking something, but something is definitely happening, and how the magician is just using all of those biases that we have to, instead of manipulating us, entertain us, right? So as researchers, we just want to focus in these 3 aspects, on these 3 subjects. And I'm going to finish really fast. So we're just going to, with the machine, we're keep doing some things. We're showing the machine what happens if it knows the trick, for example. And we're also trying to get a little bit inside and see what are the score maps. We can see that it's getting confused because it's not always the point where it shows the final result. Sometimes it's getting confused with the forehead because it looks like a hand or something. And the deep dream, we know that it sees something, but we're not sure how. So this is all opportunities for improvement. In research cognition, maybe to focus in new different ways of making research. Also improving the tracking AI, showing this object permanence, physics, so the tracking is easier for these neural networks. It can make possibilities of making better magic tricks, maybe simpler, or maybe magicians are going to have to entertain the machines in the future, so they should be already ready. And some new directions that we can have. How can we accommodate these different constraints we have so we can make comparable experiments between all of these intelligence beings? And what will happen if we tell the number of coins to a human? Will that change the experience, or will it get tricked too? So just here's the YouTube with all the videos if you want to see it. And thank you to all the people that's been involved in this project. So thank you.
Thank you, Regina. Really interesting avenue of research. And I see we already have questions, so I'm gonna go straight to it. Jan Ostrovsky is asking, the video material of a magician doing trick is already very complex, as you explained. How does AI work with simple visual illusion? Can they be a naive onlooker in those cases? Have you tried like simpler kind of visual illusion? Because it's true that these are already very high level ones, right?
Yes, we haven't personally, but I just saw a study of other Spanish investigators that they doing research just by image contrast, and the machine it still can get full, but it can see like the high contrast. It's just a really simple experiment, just showing the high contrast between images, and like those kind of illusions in which this is the same color of gray, but if you put it in white, it looks, yeah. So that kind of thing, it also kind of fools the machine in somehow. So we're not doing it, but I know there's other investigators doing that research. Yeah.
Well, thank you very much. Really interesting. If there will be other questions.